Okay, so we're going to prove this statement here in statistics is valid. The variance of x is our random variable, equals the expectation of x minus mu squared, where mu is the mean, and this is equal to the expectation of x squared minus mu squared. Now just a quick point here to this e of x squared. Now this is the second raw moment. This is the second raw moment. So I've got a link in the bottom of this video where you can see how we calculate the raw moments. Okay, so how are we going to prove this? Well, let's expand this out using FOIL, good old elementary mathematics, and let's see what happens. So now we've got expectation x minus mu squared. So that will then give us x squared minus 2 mu x, and then the mu squared at the end. Okay, now we've got an x squared, and we've got a minus mu squared and a plus mu squared. So we're not anywhere near what we want yet. But we have a minus 2 and a plus mu, so that could end up being a minus here. That could be one way. Now one way we can do this is to have a look at something called the linearity of expectation. So I'm just going to write this up here for you. The linearity of expectation. Let's hope I can fit that in on the board. Okay, so basically what it means is the expected value of the sum of the means. So expected value of the sum of all the values, so that's all the xi's. This is equal to the sum of all the expected values of the xi's. So basically that's how it's written in algebra to show you. And then this is also in terms of all the terms don't have to be independent. So independent or independence is not necessary. Okay, so therefore what we can do is here we can bring the expectation into each of these and see where that takes us. So now we've got e of x squared, so we can bring that into there. Now here 2 mu x, so now we've got minus 2 mu e of x, so we can bring the expectation here, and then plus mu squared. Okay, now with this statement here we can say that the expectation of x is also equal to mu. So I can substitute now in here a mu for this term. So that equals expectation of x squared, or second raw moment, minus 2 mu. I can substitute a mu in here for this, plus mu squared. Okay, so this will now translate into a mu squared. Okay, so now nice simple algebra here, minus 2 mu squared plus a mu squared just leaves us with a minus mu squared. So e of x squared minus mu squared, and this is the same as our variance of x. So by linearity of expectation, so I'll put by linearity of expectation. That's the rule we used to show this. Okay.